Hi everyone, welcome back to CSC 232. Today we're going to talk about other types of iterable objects. So we're going to introduce two new things, and then there's going to be one thing that you all already know. So the two new things, we've got a list, which is a collection of different values stored in order. And then we've got a tuple, which is another collection of different values stored in order. So a list is defined with these square brackets, and then everything inside of that is part of the list. And the tuple is very similar to the list, except for it's defined with parentheses and it's immutable. And so we'll get into what immutable means later. And then, of course, there's the string, which you all remember from earlier labs. You can iterate over a string, which we're going to learn about now. So these iterable objects are also subscriptable, which means you can access different elements of them. So if I wanted to pull the 1 out of A, I would do A square brackets for access 0. That's going to give me back this one. And we can see that over here, if I define my array, it's going to be equal to, let's do 1, 2, 3, and then print my array of 0. Now it's important to note in computer science, we start counting at 0. So 0 is the first element, 1 is the second, 2 is the third. And if you were to do my array 3, which we'll see in a second, so printed out 1, which is the first element. But if we go to 3, oops, index out of range, because it only goes up to 2, because there are 3 elements, 0 to 2 is 3. So just it's a common gotcha, something to keep in mind when you're subscripting into an array. Now the 2 is the third element, gives us 3. If we change this to a tuple, we can print the second element and 2. Okay, it works in this case just like an array. If we try to mix type, that works as well. So tuples and lists can contain any type. You could say 1, true, and low. So an integer, a string, or an integer, a boolean, and a string are all valid. This is going to run just fine. So there's collections in order of any data type. Going back to the presentation here. So we covered list and tuple, and then string lets us pull out individual characters. So it kind of treats the string like an array of characters. First is H, and then in here you've got the space character, and then a capital W. And so we can pull out specific characters or iterate over them. So if we have my string, let's print the second thing. So the H, or sorry, the E. Nope. 0, 1, nope, the third thing. See, I confused myself there. The true is printing out from above, and then the L is printing out from this. See the L right there. Now these could also get into multi-dimension. So an array is like it's a list, and once you add a second dimension, it's sort of like a 2-dimensional list, where each element in the main array is, or in the outer array, is an array of its own. So what this looks like for practical purposes is if you have your 2D array, let's just make a small one. So we're going to go 1, 2, and then 3, 4. If we print the 0th element, think of what you would expect this to return us. The first element in this list. Yeah, it's going to return an array. because the first element is this whole array right here. So arrays contain objects, any type of object. In this case, the objects it's containing is another array. So since we know this is going to be an array returned, we can go ahead and grab out the 2 from here by indexing into this first array, and then indexing again into the second array. So that'll give us this 2. So, another way we could do this is store it in a variable for clarity. So this is our 1D array. Oops. So here we've got our 2D array, and then we're gonna pull out the one-dimensional array from it, this first thing, and then we're gonna pull out the first or second element of our one-dimensional array. And this should print out the same thing as the last example it prints out to. Oh, great, it worked. And the same thing applies for tuples. Now, also you can mix them, right? Since an array in a tuple are just, or a list in a tuple are just lists of, they're collections of objects in order. You could put any objects in there. Since tuples and everything in Python really is an object, you can put whatever you want in any of these. So this is going to work just as well as what we had. And you'll hear me say list and array interchangeably. They're called different things in different languages. For the purpose of this class, when I say list and array, I mean the same thing. So now one of the big differences between lists and tuples. So lists are mutable and tuples are not mutable. So here I can have my list and I could change the 4th element, index number 3, this 4 to a 10, and that's going to go just fine. Let's say array is equal to 1, 2, 3, and then we can print it just so we're convinced that it is what we think it is. And then we could say array 2 is now equal to something obvious like 2, and we'll print it again. And we'll see that in the array before 1, 2, 3, the array after 1, 2, 10. Yep. So we mutated this array, we changed the values of it. Now, if we were to try to do this on a tuple, so let's change this. Let's call this tup for tuple. This is actually not going to work. We're going to run it and we get tuple object does not support item assignment. That's because tuples are immutable. So we can't say we want to switch out some value in this. And that's actually really helpful to think about when you're designing your code. You think, okay, do the values in this list structure ever need to change? And if they don't need to change, then using a tuple will keep you from accidentally changing them. So here, if you ever accidentally were to change something here, you'd get this array and you'd know, boom, or not this array, you'd get this message and you'd know right away that you should go check your code because something's not working. Strings are also immutable. So you've got your string ABC and you try to change it. So bad name. Our string is equal to ABC. Maybe we want to make it capital. Oops. Capital A. This is going to throw another error. That same does not support item assignment error. And what we can do for these tuples and strings is we can replace the entire thing. So we can say now our string is equal to ABC. Maybe we want to make the whole thing capital. So you can reassign into the value or into the variable, but you can't update the item in here with like a subscript. So I'll run this just to convince you all that it works. Printing it out twice. We get ABC and all caps ABC. So the important distinction here is 1, you're modifying this actual string, which is not allowed. In the other one, you're modifying the value of the variable, which is allowed. You can always change the value of a variable. So take a moment to convince yourself of that and think about how they're different. Oops. And then these are some examples of iterating through. So this is a good use of our for loop, since these are iterable objects, or loops from the previous lecture. We can iterate through them. That's where the name iterable comes from. So we'd say we go our array is equal to 1, 2, true, hello, 5.6. Just get all the different data types into there. And then we can do for element in our array. Let's just print the element. So this is a different way to print out our array, right? We're printing it out line by line now instead of the Python default way to print it out. But you can see it's the 0th, 1st, 2nd, 3rd, and 4th elements of our array all coming through. If we wanted to do something more interesting with this, let's make them all integers. And let's do a total. Let's add them up. So sum our sum started off at 0, and we're going to just increment it every time. We're going to add the value of our array. So add the value of the element to the sum, and then we'll print out our sum. Boom, 15, just what we'd expect. 5 plus 4 plus 3 plus 2 plus 1. Now, one thing that this doesn't let us do, iterating this way, this same thing applies for strings as well as for tuples. It's the exact same syntax, and they're the same in this respect. If we wanted to actually update our array, this part's only for arrays, as we go on, well, if you think about it, there's no way for us to tell where this element came from, and so there's no way for us to update its value here. So that's where the Python enumerate comes in. So we'll go, enumerate is this function that you can wrap your iterable with, and it'll give you an index. So now we're saying for index and element in enumerate our array, let's just print out the index and the element. So we could say the 0th index is 1, 1st index is 2, 2nd is 3, etc., which matches up with what we'd expect from here. So let's say that, silly example, but we forget what they start counting at in computer science. We can't remember if it's a 0 or a 1. Then we want to generate an array that has the indexes are the same as the values. We'll get rid of this rsum. So one way we could do that, other than the way that we just did, is we can say we'll take our array and we're going to go to the element at index, and we're going to just assign that to index. So we say, okay, go to the element at index, and that value is now whatever index is. So on the first pass of this, it's going to be 0 and whatever element is. And we're going to enumerate through our array, and then we're going to set our array 0 to be equal to 0, etc. And so we'll end up with an array 0, 1, 2, 3, 4. And there you can see it, 0, 1, 2, 3, 4. We could also do something cool, like set it equal to the index multiplied by the element, or any combination of things like that. So here we've got the 0th element, 0 times 1, first, 2 times 1, second, 3 times 2, 4th, 4 times 3, 5th, 5 times 4. And you can see that right here. And this next slide is just going over the enumerate. Yeah, here a good example would be squaring each element in the array. We can go back and do that one here. So we want to take we want to iterate over every element, but we also want their positions. So we use enumerate and use the index. And then we say our array, update the index, update the value at this index to be equal to whatever it was before squared. There we can see 1, 4, 9, 16, 25. Those are all the squared numbers. That checks out. And there are no exercises for this one. So just try to absorb that information. There will be some links posted in the description of this YouTube video for mutability and other ways to differentiate or when to use lists versus tuples and some helpful pointers about that. Other than that, good job, everyone. Keep up with the labs. All right, see you on Monday.